I want to increase it by 2. So instead of writing 2 times A, there is assignment operator which can be written like this: A plus equal to 2. Instead of writing all this means 2 times A, I am writing a single time A and then this assignment operator plus equal to. The meaning of this one is A equal to A plus 2. If you write A plus say 10, sorry, A plus equal to 10, it means A equal to A plus 10. So this is the use of this assignment operator. There are all the different types of assignment operator, uh, like plus equal, minus equal, then there is division equals, division equal, all these operators are there. So these are all called assignment operators. Okay. So in C language, this type of operators are used to make easier the writing easier. See, what is the basic difference? How it is helping us? I don't need to write 2 times this A. Okay, I am using this one. So I am using this one. See, then I am using this one. See, then I am using this one, and then I am using this one. So I don't need to write A 2 times. See, A plus plus, this is to increase the value of A by 1, A equal to A plus 1. Okay, if I want to increase the value of A by 5, then there is no operator. That's why this operator is used to make it easier. Plus equal to 5. Okay. So this is all about the different operators. So I hope it is now it is visible. So we have started with this type of operators which are having the highest precedence, the function call, then subscript operator, dot operator, arrow operator. Then comes the unary operators. Okay, then the binary into division, then binary plus minus, then the bitwise left shift right shift, then the relational operators. Okay, then comes the bitwise some operators bitwise like and or, and then the logical and finally the assignment operators, and then at the end the comma operator. Okay, there is another operator which we use which is called conditional operator. Okay, conditional operator, and which is written using a question mark and a colon. These two things are used to represent the conditional operator, and remember, this is the only ternary operator. This is the only ternary operator. All the other operators either unary or binary. Now, how this naming is coming? Unary means the operator is acting on a single operand. Then it is unary. If the operator is acting on two operands, then it is binary. Now, remember this one, this conditional operator is the only operator which is active in case of three different operands. Okay, that's why it is means it will be written like this: some variable, say variable 1, then question mark, variable 2, colon, variable 3. Okay, so you are using three different operands to represent this operator. So that's why it is called ternary operator. So if it is written what is ternary operator, then you have to write that question mark and colon. The combination of question mark and colon is called ternary operator or conditional operator. Okay, and this operator having its precedence in between this, before this, in between this. So the position of this conditional operator is in this position. Means after the logical and before the assignment operator, you can say the position of conditional operator. Okay. Now I hope you understand why we need to know the precedence. So in a break, what are the precedence table? The precedence table, first comes the function call and the subscript, all those things, and then the unary, then comes the binary, first the into division, then plus minus, then comes the bitwise left and right shift, then comes the relational operators, and then some bitwise and or this type of operator, and then the logical, and finally the assignment operator. So you must have to, don't need to remember all the operators, but you have to remember at least what are the means position in table of this operator, or you can say the precedence. You must have to remember this, because when you are representing one mathematical expression, then which mathematical operator will be executed first, and then what, you should have to remember this. That's why you have to also recall this precedence table and associativity. Okay. Now I'm going to discuss this uh, AND operator. This is this is called bitwise AND. Okay, and there is another one, single one, which is called bitwise OR. Okay, there is double ampersand, which is logical and double line, which is called logical OR. But these two having a different meaning. Just try to understand. So what I will do, first I will tell you something about our conditional statement. Conditional statement. Now generally, these conditional statements are written with the help of if and else. Okay, there is another type which is called switch case, but most of the conditional statements are written using if else. So what is the syntax of this? I hope you know, but just for so first you have to write the if, then you have to give the condition, for which condition. Okay, then in bracket the statements which will be executed if this one is true, and then the else, and the statements which will be executed if the else part is true. So this is the syntax for any conditional statement. If, within parenthesis, left and right parenthesis, you have to write the condition, then within bracket you have to write the part which will be true for this condition, and then the else part. Suppose I am taking it is like this. If so, it is like this. If you give input, if your input is say 1, you will print yes, and if your input is say 0, you will print no. Okay, so I will write it like this. If input, suppose I am taking the input in a variable say x, so if x is equal to 1, then I will print, sorry, printf yes, and else I will print no. Okay, now it means that if your input is 1, it is yes. If your input is not 1, then no. It means whether you are putting 0 or 2 or 3 or any negative value, it will give you no. Okay, but it is the condition is not like that, so it should be written like this: if x equal to 1, printf yes, and then again if x equal to 0, printf no. I hope you understand why I am writing 2 if, because here the condition is given like this: if your input is 1, you say yes; if your input is 0, you say no. So if any other value, it is not given. If any other value is given or as taken as input, what should be the output? Since it is not given, so you have to write two different if statements. If you write it like this, if else, then it is not correct. Then why? Then when I will use if else? So I will use if else in this type of cases like this. So suppose I want to check which one is maximum among the two input x and y. There are two input integer value x and y, which one is maximum? So in that case, how I will write it? If x is greater than y, then I will go to print which one is greater or maximum. Maximum is x, so I will write it like this. But and now I can write else. Why? Because if the this condition is not true, it means the reverse, that is x is less than y or x is equal to y. This either this or this, among these two, one is true. It means the maximum becomes y. Okay, so when I will use if and else, if there are two different relation, then better go for if else. If there are two different conditions, specific condition, then better you go for two if statement, or you can go for also switch case. Okay, now just try to understand the bitwise operator and logical AND operator, what is happening. Okay, so suppose int x equal to 5, y equal to 6. Okay, now just remember one thing, that in case of C language, any non-zero value, very interesting, any non-zero value is considered as true, and any zero value is considered as false. You can check it by printing. How? Suppose you printf percent d. I am writing x greater than y. So what should be the output? Now see, this is one kind of relational operator. So I am checking the relation between x and y. What is the value of x? 5. What is the value of y? 6. Is this one true? Is x greater than y? No. So it means it is false. So any false is represented at 0. So if you execute this one, you will get output 0. Okay. Now instead of writing this, if I write it like this, percent d x less than y. So what is the value of x? 5. What is the value of y? 6. This one is true. And remember, in case of C language, true is represented, or means compiler will represent true as 1. So you will get output here 1. Okay. But any non-zero value is represented as true, and any zero value represented as false. You should remember this. It is very important in case of any condition, uh, whenever you are writing any condition, this is very important. Okay, let's check. Suppose int a equal to 5. Okay, I am writing if a, printf percent, output yes, else printf no. Now what should be the output? Now what is the value of a here? The value of a is 5. Now I have already told you any non-zero value is true. So 5 is non-zero value. It means what is the meaning of this? This is true. So it will give you output yes. Okay. Instead of 5, suppose this one is minus 5. So minus 5 is non-zero. So again it is true. It will give you yes. But if it is 0, if it is only 0, then the value of a is 0. Okay. And 0 means false. So it will print no. I hope I am clear. So any non-zero value is true, any zero value is false. False means if this one is false, it will move to the else part. If this one is true, then it will move into this part. Okay. So let's check how the AND is working. So before that, another interesting thing, suppose int a equal to 0. Then I am writing if a plus plus printf yes, else printf no. Then what will be the output? This is a post increment. This is a post increment. So how post increment is executed? First it will assign the value, then it will be modified. Now what is the value of a? The value of a is 0. So the assigned value in this position is 0. Now what is the meaning of 0? 0 means false. Okay, so it will move into this part and it will print the output no. Now if I print, what is the value of a? The value of a is, if I print the value of a, since after this assignment a is incremented, so the value of a will print as 1. Okay, logic clear? Similarly, suppose int a equal to 5, b equal to 0, and I'm writing if a and b printf yes, else printf no. What is the output? See, take the value of this two. The value of a is 5. 5 is non-zero value. It means true. Then b is 0 value. It means false. Then what is the meaning of this AND, logical AND gate? The logical AND gate is like this. If there are two inputs, the output depends on like this. If 0 0, output is 0, 0 1 0, 1 0 0, 1 1 1. It means if any of the input is 0, then the output of the AND gate is 0. So this one is 0, false. So the output of this total A and B is false, 0. Okay, so this one total is false. So it will move into this part and it will print the output as no. Okay, logic clear? Now check this one. Very interesting. The logical AND. Suppose A is 5, B is 2. And I'm writing if A and B, this is not logical AND. This is bitwise AND. If you remember the tables of operators, I have shown you this can be used both as unary and binary. Unary, address operator used in scanf, Okay, and it is as binary operator when it is, and it is called bitwise and. Now see how bitwise and is performed. Yes, else, printf, no. Okay, now if I want to perform bitwise AND, then first thing that I have to do, I have to convert them into binary. So what is the meaning of 5? 5 means in binary 1 0 1. What is the meaning of 2 in binary? It is 0 1 0. Now bitwise AND means after converting them into binary, then it is bitwise AND. This bit is AND with this bit. Now it is logical AND between this two bit. So this one 1, this one 0. So if you remember the logical AND get operation, so 0, if any of the input is 0, then the output is 0. So it means what is the output for this one? It is 0. Then this one 0 1 0. For this one 0 1 0. So the A and B, the total output bitwise AND operation, total output value is 0, and 0 means false. Okay, false means it will move into this part, so it will give you output no. You can check it by writing in your compiler. Okay, but instead of this single ampersand, if it is double ampersand, then what is the output? Double ampersand means logical AND. A is 5, non-zero value, true. B is 2, non-zero value, true. Both are true, so output is true. So it will give you output yes. I hope now it is clear what is the meaning of bitwise AND. Now bitwise AND is very interesting. Why? Now suppose if I ask you check a given number even or odd. So I hope you know what is the logic to check whether a given number is even or odd. If a given number, suppose the number is A, if you perform some division by 2, if you get remainder as 0, then it is even, and if you get remainder as 1, it is odd. You know this. So since we require the remainder, so we will apply not division, we will apply the remainder or modulus operator, this one, percentage. Okay, so I will write it like this: if a modular division 2 bracket. Now what does it mean? I'm not writing the relation. I can write it like this also: if a modular division 2 equal to 1, then printf it is odd, else printf it is even. Okay, I will write it like this. But I'm not going to write this part, the relational part. I'm just writing this. It means this will return either 1 or 0, and we already know if it is 0, then it is false, and if it is 1, then it is true. Okay, now 1 means, I know 1 means, remainder 1 means it is odd and it is true. So what I will write in each part? I will write in each part that it is odd. Okay, else printf I will write even. I hope this is clear. Is it clear?
Yes, sir.
Uh, means I can remove this relation part, because it will return me either 1 or 0, and we already know 1 means true and 0 means false, and false means I will move into else part, and true means I will move into if part. So since it is returning 1, and I know returning 1 or remainder 1 means it is odd, so that's why I am printing odd here, and in else part I am printing even. Okay. Now I can do this. I can do this even or checking with this bitwise and. Just look at this. Suppose there is value a is 5. So I know a is odd. So if I write it like this, a and person 1, okay, printf. So ampersand 1 means, sorry, a and 1. What is the binary value of 5? Binary value of 5 is 101, and I am ANDing bitwise, ANDing it with 1. What is the bitwise and 1? Sorry, what is the meaning of 1? 1 is this one. If I perform bitwise AND, it will give me 1 0 0. So final output result is 1. 1 means, for this 5, the 1 means true. So I will write here odd, and else I will write here even. Okay. Now suppose a is not 5, a is 6. It is even. So if I check the binary value of 6, it is 110, and 1 binary value is 001. If I perform the bitwise AND, it will give me 0. Okay, 0 means false, so it will move into this part. So using this also, I can check whether a given number is even or odd. So this is one tricky question. That the question is like this, that you have to check whether a given number is even or odd, but without using modular operator. Then you can do it like this. Okay. And now I hope this bitwise AND is clear, then logical AND is clear. Okay. And then I will show you another interesting, just try to understand. Suppose I am writing x equal to 1 comma 2 comma 3, and I am writing x equal to in bracket 1 comma 2 comma 3. Okay. Now what is the output for this x, and what is the output for this x? Anyone? Please try.
Sir, for the right hand side, it will be 1.
For this x, it will be 1. Good.
No.
This one.
Yes, sir,
Sir,
the
for
right hand side one.
left hand side,
Right?
for
এটা কেন
left
1
hand
হবে?
side will be
এটা কেন 1 হবে? এইটা 1 হবে।
Right hand side.
আমি যা বলছি তাই ও বলে দিচ্ছে। Okay, let's check. What is the output? See, there are two operators, na? One is this assignment operator, and another is this comma operator. Now I hope you remember in precedence table which one is coming at the last. Comma operator, and before this comma operator there is assignment operator. So which one having higher precedence? This equal operator having higher precedence. So it means one will be assigned to x first, and then this comma operator will be executed. So it means the value of x is 1. Okay, but in this case I have used one parenthesis. Now this parenthesis having the highest precedence, so first within this parenthesis this thing will be executed. So 1 comma 2 comma 3, so it means what is the final value? Final value is 3. Okay, and then this assignment operator, so 3 is assigned into x. It means in this case x will be 3, but in this case x will be 1. Okay, logic clear? I hope now it's clear. Okay, so whenever you are using different operators, so you have to take care that what is the precedence, and then what is the associativity of this operator. That is very important. Okay, so I hope I have covered the bitwise and then this part. Okay, now another interesting, just check. These are, you can say, exception. Okay, so suppose A is 5 and B is 6. With this, I will end today's class. Suppose I am writing it like this. Okay, not 0, 0, not 5, 0. A is 0, B is 6. I am writing here A plus plus and B plus plus. Printf yes, else printf no. Okay, and then finally I'm printing another statement for the I'm printing the values of A and B also. Okay, now just tell me what is the output, please. I think I should ask individually. Okay, Raj Bhattacharya, are you there?
Yes, sir.
What is the output?
Sir, sir, if sir, the condition you have given A plus or is post increment. So, sir, it will print so it will print no.
Okay, so
And
first it will print no. Okay, good, correct. Then
then sir, it will print A equals to sir 1 because it is post increment.
good,
So A
very good,
equals
very
to
good,
1
very good.
and B equals to 7.
Okay, okay, very good. Are you agree, everyone? This Poco X3, who is this Poco X3?
সরি স্যার নাম চেঞ্জ করতে
না না ঠিক আছে বলো, তুমি কি এগ্রি করছো এর সাথে যা বলেছে?
ইয়েস স্যার ইয়েস, হ্যাঁ স্যার ঠিক আছে।
আর কেউ? রনিত?
ইয়েস স্যার।
ঠিক আছে?
ইয়েস স্যার, আমার দুটোই লাগছে।
আচ্ছা গুড। দেখো আমি প্রথমে বললাম there are some exception. Okay, so this is one exception. See what is the output. So the initial value of A is 0. Since it is post increment, so it will be 0. Okay, now since the first value is 0, and if you see the AND gate operation, so if any one of the input is 0, then no need to check the second input. Am I clear? If any one of the input is 0, then no need to check the other input, because whether it is 1 or 0, your output will be 0. So the same thing is happening here. The compiler will skip this one. Compiler will skip this one. Why compiler is skipping this one? Because it already gets 0 and this is AND gate, so it is obviously false. Okay, so it will move into else part, it will print no. So since this one is skipped, not executed, not checked, it means the value of A due to this post increment becomes 1, but the value of B is still 6. You can check it after my class. Please check it whether it is giving you this same result that I have told you or not. You check it, and if it is giving you any other result, means B is 7, if B equal to 7 is given, then just tell me, then I may be wrong. But this is the logic, this is one exception. Okay, it will skip this statement. Same is for OR gate. If the first one is 1 or true, means non-zero value, then it will don't go for the next value checking, it will skip the next part. But suppose in this AND gate, this A, instead of A, I am writing plus plus A. Then pre-increment, so A becomes 1, true. Then compiler must go to execute or check the next one, because from this one, it is not decided whether the output will be true or false. But if the first one is 0, then definitely the output is 0. That's why it is skipping the next one. Same for OR gate. If the first one is non-zero, then it will skip the next one. Okay, so this is one interesting exception in case of this, and the next one very tricky, and this is your homework. If I have to write some condition here I have to write some condition, then printf hello, and then
Yes, sir.
else বলো আরেকটা বলো।
স্যার একটা কোশ্চেন
হ্যাঁ
স্যার
বলো।
একটা কোশ্চেন ছিল
হ্যাঁ।
স্যার ওই অর গেটে স্যার মানে যদি একটা কন্ডিশন 1 হয়
হ্যাঁ 1 মানে ট্রু,
আর-
নন জিরো মানে ট্রু,
one
পরেরটা তাহলে
তো
দেখবেই না,
স্যার,
প্রথমটাই যদি ট্রু হয়ে যায় পরেরটা দেখবেই না।
আচ্ছা স্যার
যেমন এখানে
আচ্ছা
প্রথম, হ্যাঁ বলো।
দুটোই যদি স্যার জিরো হয়
যদি প্রথমটা জিরো থাকে অর গেটে তাহলে তো পরেরটাতে যেতেই হবে, তো যাবেই।
আচ্ছা স্যার
ঠিক আছে, লজিক ক্লিয়ার?
হ্যাঁ স্যার ক্লিয়ার
আচ্ছা, এটা খুব ইন্টারেস্টিং, এটা অনেক জায়গায় মানে এই যে তোমাদের যে বিভিন্ন টেক ফেস্ট এগুলো হয় সেখানে এই কোশ্চেনটা দেয়। সো ইউ হ্যাভ টু রাইট সামথিং হিয়ার so that your output is hello world. Okay, this is very tricky, so you have to write something here so that your output is hello world. Okay, with this I'm ending today's class. I will upload the recording so that you can go through the recordings. Okay, but still the attendance is very poor, no? Only 18 students, so I don't know that আমি ভালো
স্যার
পড়াচ্ছি না, হয়তো সেটা হতে পারে।
স্যার আগে স্যার একবার মানে রোল নাম্বার লিখেছিলাম, আবার কি লিখে দেবো?
না আর লিখতে হবে না, আর লিখতে হবে না, প্রথম ক্লাসে দিলে আর দিতে হবে।
ওকে
স্যার
ঠিক আছে।
সরি প্রথমে দিতে ভুলে গেছিলাম, এখন দিয়ে দিয়েছি।
হ্যাঁ ঠিক আছে,
বুঝলি তো?
ওকে ঠিক আছে, চলো বাই।